Hey, it's me, Mr. Richardson. Welcome to our notes today. We'll be taking a look at 1.1, our first unit here. So, first page of the notebook, our first bit of notes. We are in Unit 1. Which we'll be dealing with scientific measurements, kind of the title of this unit. And our first section, 1.1, is scientific notation. And our units of measurement. So kind of two sections here. To begin with, this video is about scientific notation, the first half of the notes. So if you're looking for the second half of the notes, there'll be a second video over that here in a little bit. So if you got the first half, you're only looking for the second half, we'll start with scientific notation. So here we go. So scientific notation. The idea is that in chemistry, in this class we're working with, will oftentimes be dealing with numbers that are either very, very large or very, very small. A couple of examples for you. 1 gram of hydrogen, which has the atomic symbol H, so we should just write it as H, it's much easier, has about, so 1 gram, that's about the mass of a paperclip. If I could give you just exactly 1 gram of hydrogen, it would have this many atoms of hydrogen. Oops, excuse me, I've got a 2 right there. So that's a gigantic number. I don't even know, how to say that. I'm not sure what the word is. Here's the millions, here's the billions, here's the trillions. So we're several magnitudes larger even than that. So it's a huge number, very difficult to type that in your calculator and get the correct number of zeros. Yet again, in chemistry, we have to work with numbers like this a lot. Another example of a smaller number, a very, very small number. If you could have just one atom of hydrogen, if there's any way to do it, and there probably is not, but if you could, it would have a mass of about, well, a whole bunch of decimal point, a whole bunch of zeros behind the decimal point, and then 166 grams. So it's an incredibly, incredibly small number. And again, we'll be working with both very, very large numbers and very, very small numbers in chemistry. So to help us write those, to help us type them into the calculator, to help us express them, so regardless of the magnitude, no matter how big, how small, even just a normal size number, all numbers can be expressed in the form of scientific notation, which looks like this: big N times 10 to the little n. So big N and little n then are variables. And it is important that we kind of pay attention to the rules for these variables. There are test questions we ask. We'll use these, and sometimes people get them wrong because they break the rules. So the first rule here, in that the big number out in front must be between 1 and 9. So it has to be a single digit number. You can have the decimal point. In fact, you usually will have a decimal point followed by more numbers, but it needs to be between 1 and 9. A lot of times I get people that try to give me double or triple digit values there. Doesn't work. Not proper scientific notation. The superscript n, so 10 to the power of n, that can be any number, any integer, any integer. So keep your math terms in mind. That's a whole number. So for this class, for scientific notation, we're not going to use decimal points. You will sometimes see them, but not proper scientific notation, because all we really want is a magnitude of 10. So a positive or a negative integer, whole number, is what we're looking for that superscript behind the 10. A couple of examples I'll show you here. So again, this is not necessarily an unreasonably sized number, 568.72, but we can write that pretty simply in scientific notation. Hey, we want the 5, and then we want the decimal point. Remember, that number out in front, that big N, has to be a single digit number. So we want the 5. The way that we get that is by bumping that decimal point out twice. So 5.6872. Because we bumped it twice, we're going to say times 10 to the second, or times 10 squared. And this value is our scientific notation for our standard value, 568.72. So when you move the decimal to the left, it's a positive integer. So decimal left, positive n. On the other hand, a smaller number such as this one, 0.0000772. Well, this time we're going to need to bump the decimal point to the right. And we need that number, the number here in front of the 10, we need it to be between 1 and 9, so 7.72. We bumped it 1, 2, 3, 4, 5 times. This time, though, we bumped it to the right. So this number here we made smaller. This number we're actually making bigger. We're bumping that decimal to the right. When you bump it to the right, it's going to be a negative integer. So because we bumped it 5 times, there's the 5. Negative tells us we went to the right. Write myself a little note here. Decimal right. Negative n. So decimal left, positive n. Decimal right, we're going to have a negative n. And those numbers from before that we worked on the first page, much simpler to express. 1 gram of hydrogen has 6.022 times 10 to the 23rd atoms of hydrogen. So this is a much simpler way to express our value there. We don't have to worry about all the zeros. We don't have to worry about getting the right number of zeros. Much easier to write this. I'm going to take a quick second here, show you guys some tricks on the calculator. And most of you probably have a calculator like this. And when we enter this, I know a lot of you guys want to hit the times 10 and then hit the caret sign. And I'm going to strongly suggest that you do not do that. There's a much easier way, a way that your calculator is not going to get the order of operations out of whack. And that way is with what I call the big E button. You can see right here. So here's our inverse button next to the -1. And above that, kind of written on the calculator, see the big E kind of in a different color. that's the button that we want to try to get the hang of using. So to kind of emphasize that now, I'm going to type this in 6.022. So all that's normal, but no time symbol, no 10. I'm going to hit second. And what that second button does is it gives me all of the yellow functions that are listed above the buttons here. And then I'm going to hit that inverse button. And so now my calculator reads 6.022 big E. And now I can just hit the 23. And there we go. That number right there is this value. So, we start making calculations, we start working on it. That's going to be something you're going to want to use, you're going to want to see. If you want to double check, if you don't trust me with that big E button, just hit enter. Look at that calculator. It gives us the number. It even says times 10 to the 23rd right there. Because that's the number we're working with. So again, I highly, highly recommend you use that big E button. Start getting comfortable with it for this class. Similarly, then we also looked at the mass of one atom of hydrogen. And again, rather than write all of those zeros, it's a lot easier just to write scientific notation. 1.66 times 10 to the negative 24th grams of hydrogen in one atom of hydrogen. All right, well, that concludes our first half of the lesson. If you want to see the notes on scientific notation, that'll be the next video, so just stay tuned.